Hi everyone, welcome to Educon Community Java interview series. So today we will discuss about the basic OOPS concept. So OOPS means object oriented programming system. So it is a programming paradigm based on the concept of the objects and which can contain both the data and the methods. So data means the variables and method means the functions. And in OOPS, the real world entities are modeled as objects. So you learned in physics, right? So there are the objects which have some mass, some behaviors, something like that. So in Java or in OOPS, this is totally objects, and objects will have the data and the methods, right? So their states and behaviors are represented by their variables and methods in the program. Clear? So what are the advantages of the OOPS? So basically, the first one is simplicity. So since OOPS models real world objects, so the program structure is clearer and easier to understand. So one can easily understand about uh, any objects, like you can consider car as object, and there the data are like car's color, uh, then car's price, like that, those things. So this is also a real world object, right? And methods like uh, steering. Okay, like steering is a object, but the function of it, like through the steering we can start the car. Okay, and through the accelerator we can speed up, or through the brake we can do the speed down, like that. So the first one is here simplicity. Then the modularity. So objects in OOPS are separate entities with their own state and behavior, and this makes each object independent of others. So the more independent, so loosely coupled. So there will be a concept like coupling and cohesion. So those things are also important for that. Then is modifiability. So changes within one class do not affect other parts of the system. So one class is independent with the another class. So this makes it easier to modify the data representations and methods. Then extensibility. So OOPS allows easy addition of new features by modifying existing modules or objects. So we can easily extend those things. Then maintainability. Then objects can be fixed or maintained independently, and making it easier to manage and debug the system. Next is reusability. So objects and classes can be reused in different programs or contexts. So these are the key advantages of OOPS: simplicity, modularity, modifiability, extensibility, maintainability, and reusability. Clear? Then what are the core concepts of OOPS? So first thing is data hiding. So for our security purpose, data hiding is one of the key feature or core concept. So through this, we can secure our internal data, and we can hide the data from the unauthorized access. Next is abstraction. Maybe this will be similar to data hiding, but a small difference is there between the data hiding and abstraction. So data hiding means we are hiding the data, but abstraction means we are hiding the internal implementation details and showing only the relevant information. So like when you will buy a car, so you know that there is one accelerator, there is brake, but do you know the internal or backend things, like when you will uh, uh, push the uh, accelerator, the car is speeding up, but do you know the internal process of it? So they are hiding that one. So that is the abstraction part. Clear? And encapsulation means bundling the data and methods together or wrapping up in a class. Okay, and restricting direct access to some of the objects components. So like when you will push on the accelerator, then speed will be up. So there are some parameters. So suppose we are keeping it as private, then you will not able to see that how much speed is up, or how much speed is going up, like that. So that thing is basically we are restricting the direct access to some of the object's components. Okay, so that thing is encapsulation. So these three are the very vital points. Maybe it is similar to you, like it looks similar, but there are some differences: data hiding, abstraction, and encapsulation. Right. So next is inheritance. So that is basically creating a new class from an existing class by inheriting its properties and behaviors. This is very real world example. You can think like uh, you are getting all the things from your parent, and parent is getting all the wealth or something like that from his father, like from your grandfather. So that is basically inheritance. There are so many types of inheritance. I will discuss those things as well. Okay, so next is association. So association defines the relationship between two or more classes. Composition. Composition is also a type of association where one object owns or contains another object. Okay, next is aggregation. So a special form of association, and where one object is part of another object, but both can exist independently. And next is polymorphism. So the ability of a method to behave differently based on the object that invokes it, enabling method overloading and overriding. So that polymorphism term came from the Greek words. So poly means the many and morph means forms. So many forms. So in that way, we can uh, use a same method differently based on the object which invokes it. So through the method overloading means the compile time polymorphism, and or you can say as the static polymorphism. And through the method overriding, that is the dynamic polymorphism, or the runtime polymorphism. Those are the two types of the polymorphism, right? So these are basically the eight core concepts here, like data hiding, abstraction, encapsulation, inheritance, association, composition, aggregation, polymorphism, right? But the main four building blocks are abstraction, encapsulation, inheritance, and polymorphism. Okay, these four are the core uh, building blocks, right? Next is, what is the difference between abstraction and encapsulation? So this is very interesting question. So I have also told you in this question as well, like explained the things between the abstraction and encapsulation, as well as the data hiding as well. But in many interviews, this question will come up, like abstraction and encapsulation difference. So abstraction basically focusing the hiding of the implementation details from the user, and it is implemented using the abstract classes and interfaces. So through the abstract classes, we can achieve the partial abstraction, but through the interfaces, we can achieve the full abstraction. Okay, why partly? Because uh, abstract classes, like they are like abstract classes uses the variables or methods which may or may not be final. So that's why that can achieve the partial abstraction, but interfaces uses the variables or methods which are final. So that's why um, we can achieve the full abstraction through interfaces. But encapsulation basically refers the wrapping up the data and methods together within a class and protecting it from the unauthorized access using the access modifiers like private, protected, public. Okay, so those access modifiers I have already discussed earlier, like through which we can access or not, like in the same class we can access or not, in the same package we can access or not, through the subclasses we can access or not, like that. But while encapsulation is about hiding the data from the unauthorized access. So abstraction is about simplifying the complex systems by exposing only the necessary features. Like I have given you the example, like when you will buy a car, you know that through the brake we can speed down, and through the accelerator we can do the speed up. But we don't know the internal backend process, like how those speed up and speed down process is going on. So the car organizations are showing us that only the important thing, like the this is brake, this is the accelerator, but they are hiding the internal process from us, right? So that will be the abstraction only. And encapsulation is basically we are protecting uh, some classes or any data members or something like that from unauthorized access. Okay, yeah. Then what is the difference between the abstract class and interface? So abstract class can have both the abstract and concrete method. So abstract means unimplemented methods, and concrete means the implemented methods. So it can have both the abstract and concrete methods, and also it can have some state like fields and constructors. A abstract class can extend only one abstract class at a time, so right, it will not, like Java don't support the multiple inheritance, right? So that's why like we can extend only one class, like the general class. So that's like in the abstract class also we can extend only the one abstract class at a time. And also abstract class can have the static, final, and instance variables. Okay, but interface can only have the extra abstract methods prior to Java 8. But also uh, onwards Java 8, we can also have the static, default, and private methods, right? And a interface means like a class can implement multiple interfaces. Okay. Um, so through this, like through that concepts, we can achieve the multiple inheritance, but like through the interface only, right? So methods in an interface are abstract by default, right? No need to use the abstract keyword. Only static final variables are allowed in an interface. Okay, so you can see here, like in abstract class, we can have the static, final, and instance variables. But here in the interface, we only have the static final variables. So that's why I was telling that through the abstract class, the abstraction may can be partially achieved, because the variables may or may not be final. But in case of interface, it should be final, like static final, like that. So that's why through the interface we can achieve the full abstractions. So abstract classes are ideal for providing a common base implementation, whereas interfaces define contracts or behaviors that a class can implement. So it's our use case to use case, it will vary, like where we can use the abstract class, where we can use the interface. So basically in an application, like when we want to achieve the partial abstraction, then we can use the abstract class. And if we want to achieve the uh, full abstraction, then we always need to use the interface. Clear? So now how can we write static, private, default methods in an interface? So basically, like from Java 8 onwards, interface can have the static, private, and default type of methods as well. But prior to Java 8, we only have the abstract methods. So in the we can be called using the interface name, like interface name dot method. Like that, we can achieve the static methods. We can write the static methods in the interface, like interface name dot method. Then can be used within the interface to provide common functionality for default methods, and can have a body and are used to provide default behavior for methods in interface. So through these default methods. So private methods can be used within the interface to provide some common functionality uh, for the default methods. Like here, here in interface, my interface, and inside that I have the one static void static method, that is private void private method, and default void default method. And we are printing like system.out.println static method, then private method and default method, like that. So now one next question is like, can we have an abstract class without any abstract method? So yes, abstract class can consist of like abstract method as well as implemented methods, like concrete methods. Okay, so that's why an abstract class can have no abstract methods. There can be only the concrete methods. Okay, so it can still be used to define common behavior, um, or serve as a base class for other classes. So there will be no issues. So next is, can we have a non-abstract class with abstract method? So no, a non-abstract class mm, cannot have the abstract methods. So if a class has the abstract methods, then it must be declared abstract, right? Next is, can we create a constructor in an abstract class? Yes, abstract classes can have the constructors. However, since you cannot instantiate an abstract class directly, so constructors are typically used for initializing the common state that is inherited by subclasses. Got it? So basically, it can have the constructors, but uh, as we cannot instantiate the abstract class, we cannot instantiate the abstract class, right? It's not total complete class, right? The abstract classes are basically the base classes. So, so we can have the constructor in the abstract class, but those are basically will be used for initializing the common states only, and those will be inherited by the subclasses. What are the various types of inheritance? So the first one and basic one is single inheritance. So one class extends another class, like parent class, um, child class extends the parent class, like that. Then the multi-level inheritance. So a class extends another class, which is turn extends another class. So like your child class extends the parent class, extends the uh, grandfather, right? So this is the multi-level inheritance. Next is multiple inheritance, that is not supported in Java. So a class cannot extend more than one class in Java to avoid the ambiguity. So suppose one is, so here for single one, I am just from parent child. Okay. So multi-level is grandparent parent child. Okay. Then what is the multiple inheritance? It will be like, suppose your class A. So that also uh, like class B extends the class A, and also class C also extends the, this is like that. Got it? Like that class B extends the class A, also class B extends the class C. That's not possible. That is basically to avoid the ambiguity. So multiple inheritance, that's why uh, like that concept, like multiple inheritance concept is supported through interfaces only. Okay. Next is uh, hierarchical inheritance. A single class is extended by multiple classes. Like here I am giving you like that. Class B extends class A, and this is class C. Okay. So it creates what? Ambiguity. Okay. But what is the hierarchical one? Like your hierarchical one is class child 1 extends class parent, right? Hmm? And the class child 2 extends class parent, right? So one parent can have multiple childs, like that. So that hierarchical inheritance supported by Java, but that multiple inheritance is not supported. And hybrid inheritance is like a combination of more than one type of inheritance. So basically the hybrid inheritance mainly like in that way I can show you like that. um, Suppose grandparent, and there here uh, in that way I am showing you. So grandparent here, then here parent. So this is parent 1, and this is parent 2, and next is here it is child. There. So this is combination of basically the hierarchical and the multiple one. So here it will create one diamond, right? So that's basically the hybrid inheritance, which is also not supported by Java, right? So this example I can consider here, right? So as per the example, this is parent and this is child one and this is child two. So that is the hierarchical one, and multiple will be like in that way. Yeah. So here you can consider it as like parent one plus parent one extends, sorry, class child extends parent one and class child extends parent two. So this is the live example for the multiple inheritance. Okay. So single inheritance is like that only, parent, and it will just like the child will extend the parent only. And in the same way for multi-level, first one is grandparent, then parent, and then child, like that. You got it, right? So single inheritance is like that, parent, child, then multi-level is grandparent, parent, child, and the multiple inheritance like the same child is extending its parent one, parent two, which is not possible for Java. And hierarchical is like that. Child one extends the parent and child two also extends the parent. And hybrid one is the combination of that. And cyclic, a class extend itself, not supported in Java as well. Like it is not possible. Like parent extends parent. This is not possible, right? So Java avoids multiple inheritance through classes to prevent issues like the diamond problem. So this is the diamond problem. Okay. So what is diamond problem in inheritance? So the diamond problem occurs when a class inherits from two classes. So here you have seen that in the multiple inheritance. So here that child class inherits from two parents, parent one, parent two. Okay. So this example I am also attaching here. Hmm. So that occurs when a class inherits from two classes that both inherit from a common ancestor. So this can lead to ambiguity in method calls and method resolution as well. So Java avoids this problem by not supporting the multiple inheritance with classes. Okay, but however, it allows multiple inheritance through interfaces. So that concept we can um achieve through the interfaces. Okay, so why do we not have an ambiguity problem with interfaces in case of multiple inheritance? like how we can achieve the diamond problem issue, or how we can resolve the diamond problem issue through the uh, interfaces. So interface only declare method signatures and do not provide method implementations. So if two interfaces declare the same method, it is not a conflict because there is no implementation. So the implementing class provides the method implementation, eliminating the ambiguity, right? Right. So if two interfaces declare the same method, suppose interface A, interface B, both are declaring the suppose speak method. Okay. So we can, it will be not a problem. Like we suppose interface um, A is there and interface B is there, and and common method is common method common method is like speak method is there. So there will be no problem because that interfaces are not implementing that method, right? So the implementing class provides the method implementation, and it will, so when will be the method will be called, like when the speak method will be called, we can use in that way, interface A dot um, speak, and when we require the interface B, we can do like that. Suppose this is interface A, the name of the interface, and here we will use the speak method in that way only, dot speak. Okay. So we are just declaring, not implementing, and whenever we will implement that method, basically like when the class will implement that method, so then we will just call in that way, interface A dot speak, interface B dot speak. Okay. Now what happens when we have the default methods of the same signature while implementing multiple interfaces? So if a class implements multiple interfaces that have default methods within the same signature, the class must explicitly override the method and specify which default method to use, right? So again I am repeating, like what happens when we have default methods of the same signature while implementing multiple interfaces. So if a class implements multiple interfaces that have default methods with the same signature, the class must explicitly override the method and specify which default method to use. Okay. So class will explicitly override the method. That will be the class's um, um, mm, work. It will be class's responsibility, which will explicitly override the method, and it will specify which default method to use, right? So this is basically the OOPS basic concept part one. Here we have discussed 13 questions. So if you have any confusions or any questions regarding that, then just comment down. I will discuss more about it if you have any questions. I have also drawn the diagram here, but still you have, if you have any questions, then you can comment down. So from 14, I will cover in the next lecture. Thank you.